right, so the request was for some practice problems from chain rule and from section 4.4 on implicit differentiation. So we'll do some chain rule and then we'll do some implicit. So this is coming to you from section 4.4. Okay, and I'm just going to jump into some examples. So remember that our chain rule states that first we take the derivative. Right, if you have f of g of x, you have an inside function and outside function, then the derivative of that, so take that prime, is going to be f prime, leave g of x on the inside, times g prime of x, right? So that's the notation. And that just means take the derivative of the outside, leaving the inside alone, and multiply by the derivative of the inside. Most likely for now, because we haven't introduced any of our special functions, primarily your inside and outside functions have to do with powers. And you're always going to see them with parentheses. So for example, you're going to have something like f of x equal, let's do example 1. Let's do x squared plus 2 to the 4th. Okay. From here, we can see that we have an inside function inside the parentheses, and that's to some power outside the parentheses. So when I use chain rule, I'm going to take the derivative, but I'm going to start by working with the outside. So I'm the blue one first. So I'm going to take the derivative of that power, leave the inside alone, and then I'm going to multiply by the derivative of the yellow part. So that means I'm going to bring down my 4, because for our power rule says we bring down the exponent, and we decrease it by 1. So my new exponent is 3. Then I'm going to multiply by the derivative of what's inside, or the yellow part. So the derivative of the yellow part is 2x. Now I can take this 4 out front and this 2x in the back, and they can be multiplied in any order. So I can put those together and make it 8x, x squared plus 2 cubed. Okay, and that's my final answer for that one. Okay. Now, how can this get more challenging? Well, number one, I could make the exponents fractional and negative. So for example, we could have f of x equals 4 over the square root of 3x minus 1. So in order to get this ready to take our derivative, we've got to rewrite the exponent. So this is the same as leave the 4, and then the 3x minus 1 comes up, so it comes up from the bottom, which makes it negative, and we're going to get rid of the square root, and so that's a 1/2 power. So that comes up as the negative 1/2 power. Then I can go ahead and use my chain rule. Okay, so I'm going to leave my 4 alone. I'm going to multiply by that negative 1/2. So times negative 1/2, because I'm bringing down my exponent. Again, this is my outside function. This is my inside. And the 4 is just hanging out in front. Okay, so we're taking the negative 1/2 times the 4. And then we're going to keep the inside and decrease it by 1. If you take negative 1/2 and subtract 1, you get negative 3/2. So that's the derivative of the blue part, but we've got to multiply by the derivative of the yellow part, the inside. And so that's going to be 3. Okay. And then I can think about multiplying across, right? So the part with the exponent is never going to get multiplied together because it's got an exponent on it. So, but this one, and this one can all be multiplied together. So if I multiply it kind of across the top of the fractions, it's 4 times negative 1 times 3, and that's going to give me negative 12. And then I've got a 2 on the bottom. And that, of course, negative 12 over 2 is just negative 6. Okay, and now I have it almost perfect, but I want to rewrite it without that negative exponent. So the negative 6 will stay up, and I'm going to move that 3x minus 1 to the 3/2 to the bottom, and that will give me my final answer. There we go. Okay. Okay, now when we start mixing and matching this with other rules, how does it go? And again, the main thing for now is that I want you to be able to do is I want you to be able to just get the derivative. So I'm not even going to simplify these this time. So for example, if we have something like x squared plus 2 to the 4th times, let's go with 4x minus 3 squared. Okay. So now you can see that I have 2 inside-outside deals, and they're being multiplied together. Okay. Now, if they both had the same exponent, everything was to the same exponent, then I would start by using chain rule. But they don't. They each have their own power. So I'm going to start by setting up my product rule. So this is going to be my function 1. So function 1 is going to be the x squared plus 2 to the 4th. And when I take that derivative to get 1 prime, I'm going to take the derivative of this using chain rule because I've got an inside and an outside. So I'm going to bring down my 4, leave the x squared plus 2 alone, and decrease my exponent by 1. Then I'm going to multiply by the derivative of the inside. Now my inside is x squared plus 2. So the derivative of that is 2x. Right? So these two pieces correspond. Okay. And then I can put together this 4 and the 2x and make it 8x times x squared plus 2 cubed. And that's my 1 prime. Got to do the whole thing with part 2. So this is function 2 over here. So function 2 is the 4x minus 3 squared. And to get its derivative, we're going to use chain rule. So I'm going to bring down that 2, leave the 4x minus 3, and decrease the exponent by 1. This time it's just 1. But then I can't forget that I need to multiply by the derivative of the inside. So the derivative of 4x minus 3 is just 4. So here I get 8 times 4x minus 3. Okay, if you want to distribute it, you can. And then we're going to put this all together using our product rule. So I want 1 prime 2, so that's these two. So 8x times x squared plus 2 cubed times 4x minus 3 squared. And that's all my first part. Big old plus sign, and then I'm multiplying 2 prime times 1. So that's going to give me 8 times 4x minus 3 times x squared plus 2 to the 4th. And for now, that's all I want you to do. Okay. So it seems like a lot, but it can be very doable. Okay. And let's do one more when we have something all to the same power. Let's make it to the 1/2. Okay. And let's make it, let's see, x cubed plus 1 over 2x squared minus 3. Okay. So now my inside is this whole fraction here, and my outside is the power. And everything is to the same power. So I'm going to go ahead and start with my chain rule. So that means my derivative, I'm going to bring down my 1/2. I'm going to leave everything inside. And I'm going to decrease my exponent by 1. So 1/2 minus 1 is negative 1/2. Then what I put here is the derivative of the yellow part. But the yellow part is a fraction. So I'm going to have to set up my my quotient rule on this one. So the top is the x cubed plus 1. And the top prime is the 3x squared. My bottom is the 2x squared minus 3. And the bottom prime is 4x. So when I put this all together here in my open space here that I've left for it, we're going to go top prime bottom. So that's going to give me 3x squared times 2x squared minus 3 minus bottom prime top. So 4x times x cubed plus 1 all over the bottom squared, which will be 2x squared minus 3 quantity squared. And for now, that's how I want you to leave it. Okay, so we're leaving it just like that. It's a little bit of a mess, but that's okay. We'll simplify it when we get to chapter 5. Okay, so there's some examples of the chain rule. Okay, and then I'll do another quick video for you for some implicit differentiation.